Base launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has
7,
started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You are looking at a live view of Falcon 9 awaiting liftoff at 12:22 p.m. Eastern Time from Launch Complex 39A at Kennedy Space Center in Florida. Thanks for tuning in for the KOREASAT 6A mission. My name is Soumya Srivastava, and I'm a structures engineer here at SpaceX. Today, we'll be delivering the KOREASAT 6A satellite to a geostationary transfer orbit on behalf of KTSat, a provider of satellite broadcasting and communication services. KOREASAT 6A will replace the current KOREASAT 6 satellite and will deliver both fixed satellite service and broadcasting satellite service to South Korea. And with its Korea Augmentation Satellite System, or KAS-2 payload, KTSat will be able to provide advanced satellite broadcasting, communication, and navigation services to civil, government, and military customers in Korea. SpaceX previously launched the KOREASAT 5A for KTSat back in 2017. This will be the 23rd flight for this booster, which previously supported several Starlink missions, 2 crew and 2 cargo missions for NASA, and most recently, the European Commission's Galileo L13 mission, amongst others. At T-minus 11 minutes and 50 seconds, we are looking good for an on-time liftoff. The vehicle is healthy and the range is ready to support, and it's a beautiful day today with only a 5% possibility of a weather violation. And while we wait, let's meet the vehicle that will be taking KOREASAT 6A to orbit today. The 2-stage Falcon 9 vehicle on your screen stands 229 feet tall. When it's fully fueled, it'll hold just over 1 million pounds of propellant. And we began loading those propellants on both stages of the vehicle at T-minus 35 minutes. Starting from the top of the rocket, KOREASAT 6A is safely enclosed inside of the 17-foot diameter payload fairing, which is the nose of the rocket. Made of a carbon composite material, the fairing protects the satellite on its way to orbit. And the fairing is made up of 2 halves, which are jettisoned approximately 3 minutes into flight. The fairing halves supporting today's mission are flight-proven, with each half flying for its 4th time today. And both fairings will be recovered after today's flight by the fairing recovery ship Doug. Below the payload fairing, we have the 2nd stage, which is the part of the rocket that will take our payload to its destination orbit today. The 2nd stage will ignite its single Merlin vacuum engine, or MVAC for short, about 2.5 minutes into flight, and then will relight a 2nd time before we deploy the KOREASAT 6A satellite. Below the 2nd stage, you can see the black inner stage, which is part of the 1st stage booster. At the bottom of the 1st stage, there are 9 Merlin engines that will get Falcon 9 off the ground and up to the thinner parts of the Earth's atmosphere. Shortly after liftoff, the 1st and 2nd stages will separate from one another. Then the 2nd stage will continue to orbit, while the 1st stage will start making its way back to Earth. The 1st stage is designed to be reflown with minimal refurbishment between flights. Today's booster is flying for its 23rd time and will be attempting to land it at Landing Zone 1 at Cape Canaveral Space Force Station. If we're successful in recovering the rocket, it will mark the 364th successful recovery of an orbital-class rocket. And lastly, the large truss structure you see next to the rocket is the Transport Erector, or TE. And we use it to both roll the rocket out to the pad and to raise it to its vertical launch position. In callouts over the nets, you may hear the TE referred to as a strong back from the launch team. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellite up until the moment Falcon 9 transitions to internal power. Okay, Now that you're a bit more familiar with the vehicle and ground systems, let's take a moment to hear from our customer for today's mission, KTSat.
KTSat은 대한민국에서 유일하게 정지궤도 통신 위성을 보유한 위성통신 사업자입니다. 무궁화 5회이호, 6호, 7호, 8호, 그리고 지금 발사하는 6회이호까지 5기의 무궁화 위성을 통해서 전 세계 위성통신 서비스를 제공하고 있습니다. 통신, 관측, 항법까지 다양한 서비스를 통해 한국은 물론 아시아와 중동, 아프리카 등 전 세계 고객들의 사랑을 받으며 글로벌 종합 위성 사업을 선도하고 있습니다. 어느 때보다 변화가 많은 지금을 뉴스페이스 시대라고 합니다. KTSat은 글로벌 우주 산업을 선도하는 기업으로서 위성 산업 분야의 빠른 변화에 대비하여 움직이고 있습니다. 비정지궤도 NGSO 사업자의 전략적 파트너십을 통해 기존 정지궤도와 비정지궤도 위성을 융합한 멀티오빗 위성 전략을 추진하고 있습니다. 여기에 더해 자체 고용량 위성 HTS 또한 추진하고 있습니다. 한국의 제1통신그룹 KT그룹의 일원으로서 그리고 세계를 선도하는 우주기업으로서 새로운 기술과 서비스를 선도하여 변화와 혁신을 이끌고 가겠습니다. 고객가치 창출을 최우선으로 생각하며 차별화된 고객 만족을 위하여 고품질 위성 서비스를 만들어 가겠습니다.
This is a great day for KOREASAT 6A. This is a great day for all of us. Everyone at Thales Space has really been looking forward to this launch. And our relationship with our customer KTSat is very special to us. We are extremely proud to provide our long-standing partner, KTSat, with a state-of-the-art satellite. KOREASAT 6A will ensure KTSat's ability to provide the highest quality satellite services to its customer over the long term and achieve a sustainable growth in KTSat's satellite business in fixed and broadcasting services. KOREASAT 6A will also improve the availability and reliability of KAS, the Korea Augmentation Satellite System, placing Korea at the forefront of secure positioning and navigation performance for air traffic. KOREASAT 6A is the fifth satellite to be built by Thales Space for KTSat. And we are proud to play such an important role in Korea's satellite communication capacity. It is the outcome of a great teamwork with KTSat. I would like to extend my congratulations to everyone who has worked so hard to make today's event happen. And I would like to thank KTSat for their continuous trust in Thales Space.
We are now at T-minus 5 minutes and 15 seconds from liftoff of Falcon 9 from Launch Complex 39A at Kennedy Space Center in Florida. At liftoff, the Transport Director, or TE, will retract in order to clear the way for Falcon 9's ascent. And to prepare for that retraction, we'll see the clamps open up.
Pressing for strong back retract.
We'll see the clamps open around the base of the second stage, and then the TE will pull away from the rocket. And so we should see those events happening in the next minute.
Strong back lower has started.
We just heard that the strong back will begin to retract away from the vehicle, and we have a great view of the clamp arms, which are opening up slowly. Great view there of the clamp arms opening up. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage and second stage should finish loading propellant about a minute apart from each other. The first stage will finish up at around T-minus 3 minutes and the second stage at T-minus 2 minutes. The white clouds you see around the vehicle are formed as the chilled gas above the LOX tank liquid surface vents overboard to maintain pressure in the tank as needed. And when that gas comes out into the warmer air, it condenses with the water in the air and then forms those clouds you see on your screen. We should be hearing the call out for LOX load completion on stage 1.
Stage 1 LOX load complete.
And there's that call out, and so we are waiting on a similar call out for LOX load completion on stage 2 in about 30 seconds. And at T-minus 60 seconds, Falcon 9 will be in startup, and that means that the rocket's autonomous internal flight computers will have taken over the launch countdown. And then, just inside of T-minus 2 seconds, we light the 9 Merlin engines for liftoff. Currently, the payload continues to be healthy, and the Falcon 9 team is tracking no issues with the rocket.
Stage 2 LOX load complete.
Awesome call out there, where now the rocket is fully loaded with propellant. So now let's keep listening as we hear the series of call outs that will lead us up to launch.
Gas launch closeouts.
You can see that white cloud from venting the TE LOX line, which is totally normal.
Falcon 9 in startup.
Great call out there, which means that Falcon 9 is now running off of its internal flight computers, and we are waiting for the go, no-go from the launch director.
LB, go for launch.
And there we have it. At T-minus 40 seconds, all systems are go for the launch of Falcon 9.
T-minus 30 seconds. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and launch. Go Falcon, go KOREASAT. Vehicle is pitching downrange. MOD propulsion is nominal.
Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center, carrying the KOREASAT 6A satellite. During ascent, we tilt or gimbal the engines, and that turns the rocket horizontally.
Power and telemetry nominal.
A maneuver known as a gravity turn. We're still going up, but now we're also heading horizontally away from the launch pad. Moments ago, we throttled the engines down in preparation for max Q, or maximum aerodynamic
Falcon
pressure.
9 is supersonic.
Great callouts on the nets. And max Q is a critical moment during flight because the combined stresses caused by Falcon 9 that are caused by Falcon 9 accelerating through the atmosphere and the ambient static pressure are at their greatest.
Max Q.
Great call out for max Q right there. The rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. Now we have 6 events coming up in quick succession: main engine cutoff, or MECO, stage separation, stage 1 flip, second engine start 1, or SES 1, boost back start, boost back burn start, and fairing separation. During MECO, we'll shut down the 9 Merlin engines, which is followed by stage separation. Once separated from the second stage, the booster will flip its orientation.
Following a nominal trajectory.
The booster will flip its orientation and begin heading back to Earth with a short boost back burn, while simultaneously the second stage MVAC engine will ignite for the first time, followed quickly by fairing separation. We should see all of those events happening back to back in the next few seconds.
Stage separation confirmed.
Stage 1 boost back startup.
MVAC ignition.
Some awesome views on the screen of those events that happened back to back: MECO, stage sep, S1 flip, and SES1.
Fairing separation confirmed.
An awesome view of fairing separation as well. We'll be attempting to retrieve these fairing halves again today once they fall back to Earth using our recovery vessel, Doug. Next up, we are waiting.
Stage 1 boost back shutdown.
And we just had confirmation that we completed our boost back burn. So it's about T plus 3 minutes and 40 seconds into today's mission. And at T plus 6 minutes and 32 seconds, we expect to have some great views of the first stage entry burn. For the entry burn, we relight 3 of the M1D engines on the first
Both
stage.
vehicles continue to follow nominal trajectories.
Starting with the center E9 engine, followed shortly after by the E1 and E5 engines, which slows down the vehicle as it passes back into Earth's atmosphere. We need to slow down to reduce re-entry forces, which ultimately helps us recover and reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but we're still moving really, really fast. And this causes the vehicle to fly through Merlin's exhaust gases, which is also known as the rocket's plume. And this deposits a layer of soot on the vehicle surface, which is why our flight-proven vehicles look so toasty. And that soot comes from the carbon-based fuel that Falcon 9 uses, the RP-1. Reusability is key to lowering the cost of spaceflight, which enables more investment in critical scientific research. And as a reminder, the Falcon 9 first stage that is supporting today's mission will be performing this entry burn for its 23rd time. It is a super clear today, and we have some really great views. You can see that both the Stage 1 and Stage 2 vehicles continue to pick up speed. The Merlins on the first stage are
Both vehicles
optimized.
continue to follow nominal trajectories.
Great callouts there. The Merlins on the first stage are optimized for sea level, and these achieve around 190,000 pounds of thrust during ascent and entry. The MVAC engine is optimized to operate in space and produces 220,500 pounds of thrust in vacuum. So after entry burn and landing burn, we will shut down our MVAC engine on the second stage, and then the landing burn will actually happen after that. And as a reminder, we are targeting a landing at landing zone 1 at Cape Canaveral.
Stage 1 entry burn startup.
And there is the beginning of entry burn.
Stage 1 entry burn shutdown.
An awesome view of Stage 1's entry burn as it heads back towards landing zone 1 at Cape Canaveral Space Force
Vehicles
Station.
continue to follow nominal trajectories.
In about 30 seconds, we will begin the landing burn on Stage 1, where the center engine E9
Stage 1
will
FTS
land.
has saved.
Stage 2 is in terminal guidance.
Stage 1 transonic.
All great Stage 1 callouts right there.
Stage 2 FTS has saved.
An awesome view of landing
Stage 1
burn.
landing burn.
We are now waiting for Falcon 9 to land back on land at landing zone 1.
Stage 1 landing leg deployed.
And there you have it. That landing marks SpaceX's 364th recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy.
Nominal parking orbit.
Stage 1 landing confirmed.
We also had SECO 1, and with that, let's return to our mission in progress. The second stage is now embarking on its coast phase, during which we're going to take a short break. And after the coast phase, we will light that MVAC engine for a second time around the T plus 28 minute mark, and that will be followed by payload deploy around the T plus 34 minute mark. So we'll see you back here in about 20 minutes.
planet, that's space. A billion years ago, when we came out of the sea of this earth, and we formed a spine for ourselves. Formed a spine for ourselves. And we reared ourselves up upon this land. And we moved unto the land. When we came out of the sea of this earth, out of the sea of this earth, and we lived in caves and were terrified, and we lived in trees and were afraid, and we finally formed cities against the night, finally formed cities against the night, are daring to do the great thing, are daring to do the great thing. And we're going into space. And we're going into space. We're going to live forever.
Welcome back to the KOREASAT 6A mission. We've had a great mission so far with incredible views throughout, actually. Falcon 9 lifted off at 12:22 p.m. Eastern from Launch Complex 39A at Kennedy Space Center. We had a successful ascent, fairing separation, and second stage orbital insertion. And the fairing halves are being recovered by our recovery ship, Doug. And it was the fourth flight for each fairing half. We also recovered the first stage at Landing Zone 1, which marked its 23rd landing. We're now moments away from a second ignition of the MVAC engine on the second stage, which will carry the KOREASAT 6A payload into the orbit needed to deploy the satellite. This burn will be followed by the shutdown of the MVAC, also known as the Second Engine Cutoff 2, or SECO 2. Now let's wait for those callouts, which should be happening in the next few seconds. An awesome view of the MVAC, which has now lit up for its second burn. In total, this burn should last about a minute until we have SECO 2.
Nominal orbit insertion.
And with that call out, we have second engine cutoff, or SECO 2, and we're now just a few minutes away from payload deploy. Our customer for today's mission is KTSat. And KOREASAT 6A will deliver both fixed satellite service and broadcasting satellite service to South Korea, and with its Korea Augmentation Satellite System, or CAS-2 payload, KTSat will be able to provide advanced satellite broadcasting, communication, and navigation services to civil, government, and military customers in Korea. We had an awesome view right there of the payload, which is the CAS payload, and that is a government project led by the Ministry of Land, Infrastructure, and Transport. CAS is the 7th satellite system globally to be officially recognized by the International Civil Aviation Organization, which is a United Nations agency that sets standards and regulations for aviation safety. CAS is expected to improve the GPS position error distance in real time to ensure positioning reliability throughout the country. And we continue to have beautiful views of the second stage intermittently as it prepares to deploy KOREASAT 6A. And that payload deploy should be coming up in about a minute and a half from now. And as a reminder, our customer for today's mission is KTSat, and SpaceX previously launched KTSat's KOREASAT 5A communication satellite back in 2017. We will continue to have views, and we will have views of payload deploy, which is in about 15 seconds from now.
KOREASAT 6A deploy confirmed.
And we heard the call out, and you can see right there, we had successful deployment of the KOREASAT 6A satellite as it moves away from stage 2. And that wraps up our coverage for today. Thank you for joining us for SpaceX's 107th successful launch of 2024. All of us here at SpaceX want to give a big thank you to our customer, KTSat, for entrusting us with today's mission. We also want to give a shout out to the Eastern Range and Federal Aviation Administration for supporting today's launch. And as always, thanks to all of our viewers for tuning in and your continued support. Remember to follow @SpaceX on X for launch updates, and join us later today for a Starlink launch from Slick 40. Thank you, and we'll see you again soon.